Hello and welcome to the first ever episode of Fern Flat Earth Research Network. And today with me is our investigating group leader for this specific project for our new map, Flat Earth map, Terrestial zero point 0.1 live from Fern. It's Celino Villanueva. Welcome, Celino. How are you, brother?
Very well, my friend. How are you?
Good, good. Nice to have you here.
Well,
So
let's.
we've been working on this map from past 6 months, and today is a special day. We wanted everyone to share this with everybody for our holidays and seasons we have been going through, and we've been working so much on this. So our partner is going to let you more information about this. Salino, go ahead.
Yes, it is very important this day because it's the first time we have an approximately real flat Earth map. But it's not a flat Earth map. It's a standard Earth map, a real one, based in one a new methodology. But the problem that right now is Gleason is not a real map. It's a projection. It's a projection of the azimuthal map, North Pole. And right now we have been investigating the path of the sun, and I will explain you everything right now.
Okay. So we've been. This is mainly based on upon the observation of the sun that our team has been doing from past 6 months. So what we've been doing is we are using different applications like Dioptra and Sky.net to follow the sun, which is really local. And based on that, we have a method of calculating the distances with the speed of the sun. Yes, Salino.
Well, we will explain everything. This don't gonna be so fast, but it's very important to understand all the project. Okay, let's do it. I have my computer.
Exactly. Okay, I'm gonna share your screen.
Yes,
Yes.
and expand all the screen to full screen.
Yes. Are you sharing right now?
Yes, expand the image to full screen. Okay.
Yeah, one moment.
Yeah, let's do it.
Perfect.
Well, hello, my friend. This is Samna, the Oracle from Celino Villanueva. From well, my English is not so perfect, but I expect that you understand my point of view. Okay, let's do it. This is my Spanish presentation normally from my channel. Well, not everybody have the guts to present to present a map because we know that we don't have all the tools that we need to create a map. But I think that we have a methodology that is very perfect that help to the community to improve the Gleason map and have a real projection of the Earth. We are presenting right now the version zero point 0.1. Let's first check what sets Neil deGrasse Tyson about the shape of the Earth.
It's something else. What is it?
You are not listening, right?
Because my book says
Yeah, we can hear it.
I almost don't listen.
Want to be high, you're measuring your distance from the center of the Earth. The very center. Is that different from the center?
Well, we know to Neil deGrasse Tyson, he did explain that the Earth have some kind of pear shape. The pear shape in some way is because the south part of the world, in his opinion, is bigger than the north part of the Earth. So, well, this is a pear. Some people said that it's very slightly, but he said it's like a pear shape. After that, he tried to explain that maybe is some kind of projection that it's a perfect sphere, but the science normally said that the south is bigger than the north. In in our measure and our observation, this is like that. This is probably real. We use normally the Gleason map projection. Um, This means that maybe the Capricorn tropic is
The Tropic
bigger.
of Capricorn. Yeah.
Yes, is bigger than equator or Cancer. In an sphere, uh, Cancer must be the same size that Capricorn. So
Yeah.
let's check if this is real. Okay.
Okay.
Okay. Normally the prediction that this is a perfect sphere. This is not a pear. But if it's a pear or if it's flat, Capricorn must be bigger than equator. Okay. Neil deGrasse Tyson said that probably in a cosmology level, the Earth is an sphere, but nobody knows what that means, because cosmology cosmology projection is not a real measure. It's not a data, so we cannot
Yeah.
to talk about that. So
Okay,
let's
so
see
it's
what
like saying
happens.
also, like if on a plate, the center part of a plate has less area covering than the outer part of the plate. This is what also what you're trying to say, right? The square miles near the Tropic of Cancer have less square miles than the Tropic of Capricorn, right?
Right. We didn't study in the Spanish countries. All the my communities from Spain, Spanish country, Spain, Mexico, Ecuador, Argentina, all the Spain countries, most of America, part of Europe. We have some contacts in Australia, in Japan. So we try to measure the Earth doing our own observation, not based in nobody. We do this research about 6 months. We takes hundreds of measures using cellular phones, using dioptra, and using regular observatory, apps. And
Yeah,
we
like
try,
Skynet.
yeah, we try to cover our own measures with the observatory measures. And finally, we reach that probably is the same. So we think that observatory really notice where the sun is observed over the horizon.
Exactly.
So
Yeah,
we
so
we think
according to these applications, you could measure the angle of the sun through these kind of application, and you can know exactly the locations of the sun by different application like sky.net, that we can see that the sun is really local. Okay, so this was because of the movement of the sun, these
no,
measurements and calculations are possible.
not exactly that. We are trying to measure what is the real position of the sun in the sky, not if it's local or not. We are trying to
Yeah,
see
yeah,
what
exactly.
is the position. Okay,
Yeah,
so
yeah,
this is our observation based in dioptra. So we do the measure, we do shadows, and after that we try other kind of measures. And finally we found dioptra in Android. That is a very good tool, that is the same that use the shadow to measure the real position of the sun. And to the same time, we confirm that the observatory really shared the real position. So these numbers are real. The application said that this is observed 20.4 degrees
degree.
over the horizon. This is I don't know how to explain, but I will say in Spanish. You try to um, you know
Yeah,
percibida, posición
yeah, how to
percibida.
perceive. Yeah, the perceived position is not the same like the real position of the sun, right?
Well, we don't discuss right now what is the real position of the sun, but the observatories don't set the real position of the sun. They set the observed position of the sun. But we know the observed position of the sun is not probably the real. So the question is, where is the sun to do these measures? we we did the different evaluations based in 5 6 months about the position of the sun if it's really 149 kilometers away, we try to measure the height using the regular, the regular um, science about the shade of the earth. And this is not real. By example, from Pamplona and Ushuaia, the horizon position of the sun is 28%, 16%. So this said that the sun is probably under 21,565 kilometers. So it's very, very far away from 149 kilometers. So
Yeah,
the
that's the
regular,
traditional science. Yeah,
yeah, yes, the regular model, we cannot confirm the regular model is real in any way, and trying to do different point of view. All the community had tried to have tried to investigate this, like FECOR and other groups, and
yeah,
nobody could measure what is the real position of the sun. But we found a solution. So the first approach is that we understand that the maps are probably not real. Everybody know this. If you don't know this, you must to Google it, search about this, and check that probably all the maps of the world are wrong, because give a shade of the lands and give a position of the lands that is not exactly real. Mercator was like a Frankenstein map, because they receive a lot of maps from many places of the world, and they construct this world. We grow in this view of the world in the last 500 years, but it's probably not real. In the last year, we has been checking this observation of the world is not real. Everybody is looking for a new model. So
exactly.
Mercator is the base of the maps that we have today, and all the maps of the world are based in Mercator. That is very strange, because 500 years ago they found something like the real view of the world. Is very difficult to believe, especially when
Exactly.
that all the lands right now are very mislead, and not all the
It's
countries
not correct. Yeah.
and
Although doesn't the map don't match up with the real figures of the earth, like what we really the distances. Yeah.
and every country try to show his country more powerful, bigger, more important. So this information that looks like it's so open is not real. China is not sharing detailed maps of his lands. That's not. Everybody think this is so easy, but it's not, because not every country permit take this kind of point of view. So it's very strange, but it's very weird that Google Earth said that they understand the world and they have a real point of view of the world. All these kind of maps that we know, like the Patterson, Sinum, Orbit, and all these kind of maps are based in different point of view, in different data, and finally they have different shapes for the world. That is very strange, because everybody think that this is the world, and it's not.
Exactly. Yeah. It's just copying and pasting and different kind of different maps and just creating any form of maps. That's what's really happening. Yeah. From all these 200-300 years.
Yes, yes. So in the last project of the world, there are many different groups trying to create the real map of the world. At this moment, we think the real map of the world is Google Earth, but Google Earth is based in Autograph World Map. That is a new version of the world, and this version start to look like the flat Earth, my friends. I don't know if you're seeing this map. This is a very interesting map. I hope that you search and you try to study a little more, a little more. But it's very interesting, because show that these continents are pretty far away, and this
Yeah. The shape
this
is
is
not matching.
this
Yeah.
is this this is starting to show something more like the flat Earth, that we normally use, the flat Earth map that we normally use, the Gleason. We know it's not a real map; it's a projection of the map, but was not built like a map. So Googler said that they create the autograph world map, and this is they use this base to create the Google Earth.
Google Earth.
Google Earth.
Yeah.
We know the Google Earth right now, and everybody think this is the real world. Finally, we got it. After thousands of years, we know exactly how is the world. For real? For real?
It's a joke. That
For
Google is
the
a
first
joke.
time in history, you think they got it or this is fake? Well, I will prove first this probably is fake. After that, I will present our point of view, what is the map, and we have a methodology that solves all this problem in the persecution of a real standard map of the world. The first flat Earth map that we consider that is probably very close to the real. So the day has 24 hours, and the sun normally travel 24 hours to back to the same point. It's very weird that
Exactly.
they said that the sun is pretty far away, but in all the sites they show where is the sun. They said the sun is here. How can be the sun here? If you said the sun is 149 kilometers away,
Million, yeah, million miles.
why all the observatories of the world show the sun in a place like a real very close thing? They said the sun is here, 153 west, 22 south. They said this here, and we think probably they are right. So we are using the flatter map, and we are adding, we are putting the position of the observatories, you know
Yeah.
to try to do an investigation. This investigation is based in the observatory view. Where is the sun? You know, this is
Exactly, the
official
movement. Yeah,
information.
the movement of the sun. Yeah, this site sky.net, you can see exactly where the sun is at a given point of a day, or exact time or second. You can see where is the sun. So what is being done is that the movement of the sun in every 24 hours is like covering a distance, no, of 15 degrees or something. That's the base of the point where we are going through. Yeah.
Yes, yes, but let's go step by step, because we are trying to go step by step so the people understand what is the next movement. So the first thing is that we put in a place where is where they see the sun, the observatories, and this is confirmed by our community, because we do this research 6 months, and we confirm that the observatory point of view, what they share about where is the sun, is exactly what we see. So, what is the real position of the sun? The real position of the sun is is when you don't see shadows. When you don't see shadow, that is the place that the sun is exactly in the zenith. You know, this
About,
is
yeah, 90-degree above you. Yeah,
yes,
90
this is
degrees.
shared by the regular science and by flat Earth science, we can say. So, if
Yeah,
there
both
is no
agree on this.
shadow, probably there is no reflection. That is the real position of the sun. So, the um, the observatories, the sun observatories, said that in this place, at this moment, there is no shadow. So that this means this is the right place where is the sun over our head, probably not so big, and we are using this data to do this research. Okay, so let's check what happens in the reality. Okay, we see this. We will use the 21 December 29 this year, because it's the saddest point of the sun. Where is
Yeah, when it's in Capricorn. Yeah.
Capricorn,
Yes.
and it's the highest speed, and it's a regular speed. We check this in our own evaluations, and we think this is a regular movement because some people said that if we do, not some people, we know, if we mix different speeds from the sun, probably
Yeah.
the data can be mislead.
Y-
This,
Yeah. Maybe because they say that in the Tropic of Cancer it is moving much more faster. So
right. So we choose one day of the year, and we choose the SAT, because we looks like the most regular speed. So we think that in this day the sun is going to regular speed. So the science said that 15 degrees by hour is what Earth moves, and we share with the community that this is with that is a circle. 24 hours, 15 degrees by hour. They are talking about a circle, and we think it's a circle. You know, the 15
yeah,
degrees is just the arc 15 degrees from a circumference. Okay, so a circle.
exactly.
Okay, let's do it. So the sun getting Africa to the third 34. You see,
Yeah, 334. Yeah,
334. Sorry, because this is not so fast, but it's very important and it's very interesting, and will your mind will explode. Okay, let's
exactly.
do
To
it.
understand, yeah, then the map we want to present is very important that we understand how and what method we have been used to get this accurate calculations and measurements of the size and distances of the map.
Okay, to the 5 a.m. we see the sun going out from Africa. So it's
Yeah,
exactly 1 hour 26 minutes. You know, 1 hour
exactly. Yeah,
26 minutes. What is the
that
what
means
is the what is the distance that record? With the distance is this tropical the Capricornio. Well, let's see this. This is the information that shares Google Earth. Right now, we are trying to understand if this map is real or not. So we will use this data for now. But at the end, you will understand that the data probably is not so perfect that the people think. Okay, let's do it. So let's measure using Google Earth. So this is like around, this is not perfect
that
because it's an example. you know it's probably
yeah,
probably something like that is 2000 kilometers. Sorry, because I work in kilometers, it's more easy for me. You can put in miles and you can try to move this to miles, but I normally work with
yeah,
kilometers.
around.
Okay.
Yeah, no worries. Go ahead.
Okay, so this is very interesting. 2000 kilometers is the size of Africa, sets Google Earth, and 1 hour 26 minutes is the time that we
The
last to.
sun took.
Okay,
Yeah,
okay, okay. Let's do it. Calculator. So 26 divided by 60 is minutes plus 1 is 1 hour 43 dividido por 24 hours.
divide that.
So 0.05972. I don't know if you understand, but we are trying to measure what of the total circumference is Africa. 360 degrees, so 21.5. You understand? So
Exactly.
this is
Yeah,
an arc of 21.5. So let's go to the Gleason map for now, because this map is not so perfect. So Gleason map says that Africa is around 15 degrees, so it's wrong. So
exactly.
Africa
Now, yes,
Africa probably is around 21.5, because this is what says the sun. You know, you
exactly. The
understand the
sun is,
sun.
yeah, yeah. Every 15 degrees, that every hour the sun moves is covering one part of the 15 degrees of the 360 degrees. Yeah,
So what is saying the sun is that in a flat Earth map, probably the Africa is bigger in the south. Okay, let's
Yeah.
let's back this later. For now, it's very interesting our calculation. Our calculation is that the size of the Earth is the size of Capricorn is 21.5 degrees. 21.5 is to 360, like 2063 is to x. Okay, so using Africa measure the Capricorn, our final number is 35,765. This is weird because it's not exactly the number that they share normally.
True.
Size of Capricorn. I will use in Spanish. Tamaño,
Oh, yeah, yeah. Del
tamaño,
trópico de the Tropic of Capricorn.
tamaño del trópico de Capricornio. Mm, this don't say it's how long is. You search the data, my friend. I will continue.
Okay.
Okay,
All
so
right.
we move. We with the size of the Capricorn is 35,765. Okay, using Africa. Okay, let's go to South America. Okay, from Africa gets out the sun from 5 a.m. Around 9 a.m. the sun is getting America close to Sao Paulo. Okay, close to Sao Paulo. This is
Yeah.
very, very interesting. A first very interesting thing is the sun is observed in the solstice, no?
Yeah,
The
solstice.
solstice in 22.8, 22.8. It's very interesting. 45.4, 22,8. 45,4 W, 22,8 S.
Yeah, the Tropic of Cancer is about around 37,000 kilometers, around 22,800 miles.
How much?
37,800 kilometers.
33?
No, no, no. 37, almost 37,000
37,000.
kilometers.
Okay, it's very different that what the measure that provide Google Earth using Africa to measure, because it's 35,000.765.
So it's showing much more less.
So it's different. It's interesting. Okay, let's do it.
Yes.
This is the saddest point where it was seen the sun, and it's not in Capricorn. It's 72 kilometers away from Capricorn.
True.
So what happens? The sun is not don't pass by Capricorn exactly. Every
It's
every
it's
year, every year change. Well, probably every year change, and this is the reason because the people expect to see in the old days where is coming the sun, because if the sun getting here or getting later or getting before, probably in my opinion right now, because I has been studying another history things, the weather in the year will be better, you know, the
yeah, yeah.
the change. So I am study what means the sun don't touch Capricorn or touch or goes after or goes early. This year is coming early, you know? Interesting.
Yeah.
Well, let's do to measure Capricorn. We know
Yeah.
we see the sun is not exactly over Capricorn, so we try to measure. M is 262 kilometers in America, 266. But right now we are measuring the sea
Okay.
from Africa to America. It's around 6,000. It's a little less because it's not exactly like this. We would use this point, 100, 100, 100, 200, 100. We are doing different measures. Um, we will do again. Sorry, because I don't notice the first. Okay, but
Yeah,
this,
what we try to say is that there are many anomalies in the normal Google map and the other maps. Like it's not the size of the continents are not right. The seas, the distance between the seas, also, and the equatorial lines also is not right. The Capricorn is supposed to be much more higher, and same with the equator, because the sun is what is the reason here, because the sun cannot be, because the sun have the special, like the speed what is going through is all the time, it's 15 degree per hour. That's the speed of the sun, a regular speed, not in the north, not too much in the south. So this is where we are getting our data from, the movement of the sun, and according to the different applications and all this calculation we're trying to get,
this is just
because the
uh,
sun doesn't
this is
lie.
just an explanation. Right now, we don't need to be perfect. This is just to show the way that
Demonstration. Yeah.
yes, it's
The
around
method you
6,000.
use.
It's around 6,000 kilometers. You know, it's around six
Yeah.
thousand kilometers, 6,100 kilometers. 6,100 kilometers is the measure. 6,000 if you do a straight line, but the geodesic they put different, so it's not perfect. But 6,100. So if we use 6,100 and we do the same kind of measure that we do before, so is how much is this? Um, 4 hours, right? From 5 to 9.
Yeah. Yeah.
For 5 to 9 exactly 4 hours. Four
Because
hours dividido por 24 por 360 grados es igual a 60 degrees.
that the sun covered 60 degrees in 4 hours. So
60
yeah.
degrees. We goes to do this map and we move. Well, that right now is perfect. It's almost perfect because we move Africa. We
Yeah.
move
We did
Africa,
Africa. We
and
already did
right now
Africa.
we have 59.6. A little,
Yeah.
a little, a little. Okay, right now. Okay, perfect. So this is the real position in a flat Earth map because we are measuring this. This is just Capricorn, and we try to. We have more data later. Okay, right now we are just covering this. Okay, let's do it for 60.
60
So
degrees
60
in
degrees. Well, in the point of view of the sea from Africa to America, we covered 60 degrees, and they said this degree is 6,100 kilometers. So what is the size of Capricorn using this data? Just um, using this data. So is
Exactly.
60, 60 to 360 is to 100 to x. Okay, so is 661 360. See what? So 30 36 600.
Thousand. Yeah.
Not different again.
Exactly. It's
Different.
around 800 kilometers difference.
Yes, it's different. It's strange because this probably must be more accurate. Okay, and we try to check this in all Capricorn in Google Earth map, and we found many difference
Anomalies.
between from land
Yeah.
to other. So this is just a construction, a CGI construction. They build this and they try to measure to looks like an sphere, but it's not real. But let's see what happens in Capricorn. In Capricorn, the length of these sides is around 200, 600. This is the size of America. 2644, okay. From 9 a.m. get in America. What time goes out from America? It's like 1 hour 30 after. Okay, 1 hour 40 after goes out from America. So from that up, from T40, 1 hour 40, what is in degrees?
One hour.
40 dividido por 24 es igual por 360, es igual 25 degrees. So
Yeah.
America's
Just
sides must be 25 degrees from an sphere, so it's bigger. So we
exactly
take this.
10, yeah. 10 degrees more than the normal 50 degree. 15 degrees. Yes. So it's around 1000. Should be around 2000 kilometers around.
It's like something like that.
So it have to be more. Yeah, it's have to be more broad from at the Tropic of Capricorn, even South
Yes,
America.
if we do this same exercise, we probably found
The same with Australia.
Australia a little higher. Some people think that is closest, but not. The sun shows that is in a different place, and we are checking right now what sets the normal Google Earth about the size of Capricorn using America. So let's see what happens. So 25 degrees to 360 is the same that 2644 to x. Okay, so 2644 for 360, 25 degrees, 38,000 kilometers. So what is going on, my friend? Because if you use Africa using the path of the sun, they said that Capricorn must be around 35,000 kilometers. If you use the sea from Africa, they said it's around 36,600 kilometers. And if you use America, you see that is around 38,000. So the sum proves that Google Earth is fake. You know,
It's wrong.
it is probably is just a
A
construction.
CGI.
It's just a
Just a
construction.
CGI.
They build this. So what is the real map? We think that we have many data about this. All the maps of the world show the pole north is probably the center of the world. We share this point of view. It's not the investigation of this live, but probably that is the truth. So the second point of view is that Capricorn is bigger than equator and tropical of Cancer. How bigger? When, in our opinion, when the science says that the speed of of the Earth is 166 kilometers, 166, very
One,
suspicious number,
yes, the
for
magic for them.
24
Yeah,
is around 40
around 40,000.
40,000
Yeah,
kilometers. So we measure tropical Capricorn in 40,080 kilometers in our point of view.
yeah,
And this is probably the real size, yeah, the real size of Capricorn,
Capricorn.
approximately the real size of the Capricorn. So what is the second point of view to build a map? So we use just one day, just one day, and we try to create points like a key drawing, to try to measure. This is where is it Sydney, this is we see Perth, whatever. We try to create this. After this, we create a projection. We use the North Pole like a real projection. What is the problem about this? There are several problems, but it's a first approach to the final map. And we think that we improve the Gleason, and it's the first improve that we have for this. The problem is that observatories and all the regular information about satellites, well, we know about satellites, but all the information that provide regularly the astronomy and the science, regular science, it is only reach until 80 north. After 80 north, we don't have any information that is not public, at least. Having the science about the sun after after
Exactly.
80 degrees, they don't share information that we just can't understand what happens in this
Part
area.
of the Earth. Yeah,
Is this
everything is unknown above 80 degrees
the
north
pole
and 80 degrees south.
the pole north? We don't know exactly what is the size. We don't know exactly what is the size. For now, we use the size of the regular science because we don't have more information about that. So this is a this maybe this is bigger. Looks like bigger, but it needs a new investigation. Okay, all the rest is very regular because looks like Gleason was not so wrong. Looks like Gleason was not so wrong. We check airplanes flight. We check the path of the sun.
The routes,
Yes,
yeah, the
we have,
routes, the flight routes, the sun, the speeds, and everything matches with the
yes.
Gleason map. There
Not
are
not
and
not
all and
not don't matches with the Gleason map, but matches with our new map. Is
exactly.
more accurate. So what is the third part of this investigation? We check that if we freeze the sun in sometimes in the same day, it's the same speed, so we can evaluate the position of the countries using the path of the sun. By example, if the sun is here, at this place,
Yeah,
exactly going out from America, we try to measure this point. Bogota is looking at the sun 61 degrees. You know,
yeah, the angle.
okay, you can try to understand this because it's very interesting. And Fortaleza is 53 degrees.
Yeah,
So Fortaleza is farther from the sun from Bogota. Okay?
yeah,
Salvador is closer, and probably this city at this place, you know, is at the same distance to the sun from Bogota. It's equidistant.
yeah.
So if some place look at the sun to the same degrees that other place, just this place is equidistant from Bogota. So
True.
we we
Yeah,
can we can try to measure the shades of the continents and the real position of many places of the world using this methodology, the path of the sun. That is very perfect and is probably the best methodology that we can found. And we can use the data from internet to create a real map of the world. You know, we
Exactly. Yeah.
we try to measure this using Google Earth. We know it's not perfect, but probably it's very close to the real in the Google Earth case in some distance sites. And this probably is like I said, uh, the places that see the sun to the same degree are equidistant to the position that is seeing the sun at that moment. So this is a second rule to build a map. Where is
Yeah.
exactly
It's kind of
China? Where is
kind
exactly
kind
this
of
place?
triangulation.
Yes,
Yes. Triangulation.
yes,
Yeah.
that help us to put more places filled with more points. After 40 hours measuring this data and taking some observation, checking up the position of the sun in different moments of the day in 21 December 29, we cannot use another day because maybe it's a different speed. So we just use this day. So we finally reach to this map. Ta-da!
Here it is.
Let's do it. Pantalla completa. This is our document, PDF document.
Yes.
This is the
And
document where we show how is the Earth probably basis in the path of the sun. Looks very similar to Gleason. It's not because it's based on Gleason. It's because Gleason is probably very close to the real observation of the map.
flat.
This is not a copy. This is a new map. We improved 10 positions from the Gleason map. Australia, shape and ubication and location. Africa, shape, location, and size. Madagascar, position and shape. Capricorn, approximate size of Capricorn. So right now we have some measure to try to create more measure and improve this map. A approximate calculate of the size of the Earth, uh, position of South America, shape of South America, form of the ice, and longitude. We use the regular information about the ice. We have some doubts about this, but looks very interesting that probably this is the real shape of the ice, and this is a real position of the ice, and it's not so big. Many people said it's thousands, hundreds of kilometers. In our investigation, the size of the ice is around 69,000 kilometers. Circumference, Earth circumference is around 55, 70, 60. It's not so big. It's not so big like some people said. If the Earth is flat, it's so huge that it's not real. It's not so big. It's very understandable. And this is the way that everybody can study our map and do improvements using this methodology. So this is the map of the firm. Let's do a close up. We have the map in a very high,
High
you know,
quality. Yeah.
high
Yeah.
quality,
There are
so the people can
exactly
print.
yeah, people would accept some map like from another world, but it's the new map that it's the a betterment and improvement of Gleason map where we have few notable changes, and it's our first change is 0.1. That's why it's not this is not a definitive map, but it's the first step to the flat earth map 0.1. And we have changes like in Africa, the size of Africa in the South America is much more higher than the equator. There are many different changes Australia.
This is our unknown lands because all
Okay.
the maps said there is lands here. Many people
Yeah.
think that probably there is lands here. So we put
Yeah.
this in white because looks like
We don't have
unknown
info. Yeah.
lands. Yes, we
Yes. No
cannot.
landman.
We don't know the size of this area. We don't know if this area has or not lands. We cannot prove or we cannot disprove the science. And the ice, we think that the ice is very proven that exists. So this is a reason because we use this shape of the of the ices because this information is provided by observatories and so geography data, so it looks like real, looks like all the of the world is surrounded by ice, looks like
Yeah,
maybe
but this
it's
is
a
what.
little
Yeah, this is
different,
what.
but it's a very good
Yeah.
approach for the real.
Exactly. We have shown this as ice because this is what information we have, that it's supposed to be Antarctica and ice, but this could be land, whatever. We have marked it as unknown land.
Well, my friend, this is the data from Fern, and we did very several confirmation on this live. The first one is that the maps are wrong, the size of the lands are wrong, and we proved the Google Earth is probably wrong because they share information based in Capricorn, where you see there is not, there's not similarities. If you use Africa, Australia, Madagascar or a different point of view, you get different measures for Capricorn. So that is not real. So that is not real. After that, we use the path of the sun. That is very, very, very accurate. This is real. Is that's it, my friend. That's the
Yeah,
path of the sun.
this is all based on, yes, this is the sun is what is the reality. The sun what is
Refutable.
giving you speed.
This
Yes, you
this is
cannot debunk the sun. Yeah.
esta es evidencia refutable.
Exactly. Yeah, you cannot debunk this idea because there is a sun which is giving you the measurement. The sun is what is giving you the distance. The sun what is giving you the speed, and that's how you could uh, do all these calculations. Exactly. And you can find this map. It's downloadable map. Down. You can download it from our site, Fern site. We have. You can download it also. We're gonna upload it on our Facebook page, and you can also join our group of Fern. We also need people to join in, and for our observations, you can join with our group wherever you are in the world, because even the smallest data could help to build this map from 0.1 to 1.0, which is our next goal in the future.
Our next goal is to build a professional map, hire professionals. We use right now 40 hours of work to create this map. Probably this needs 500 hours, maybe 1,000 hours to measure every city of the world, not just regular shapes of the continents. We need to try to locate every city of the world. And my last message about this is that when we measure this using the pass of the sun and we use it 24 hours, finally we reach the circle is perfect. This is not this doesn't happen if the earth is not flat. So the information of the path of the sun show the earth is flat because this is very ¿cómo se dice que coincide? This
Yeah,
match
there is
this
coincidence.
match
Yeah,
with a flat earth. This match with a flat earth. So it's a new evidence that probably we are in the right path.
exactly. And Gleason and Mercator didn't had these applications and these softwares and all these cameras to exactly, precisely can match up with the sun. And we in this age, we are having these kind of tools in our hand. We have internet. We have people all around the world. We could start from this, right from the modification of Gleason from right now, from 0.1 to our next step. We all can chip in. We all can give in and make and grow this map. So you all are welcome to join in and give your part too.
Well, my friends, I will do more lives about this map and our investigation. You can go to the Fern site and share with us information or collaborate directly because we are looking for a sponsor to do a real map and try to do a real research that help to improve our first approach to this map. If you think this methodology is interesting, you can contact to us and work in a project together.
Exactly. We do also have our Patreon if people want to join and collaborate, because our next project, apart from doing this map from 0.1 to 1.0, we have even our pipeline many other projects, like going and making a documentary about the Himalayas and shooting Himalayas from at least from 2 hours of distance. And
Yes.
then and the other ones would be like taking calculations from the Ecuador, from equator, about magnetism and light, and trying to debunk Coriolis effect. And then other projects would be professional instruments to construct a flat earth map and model. And then also on our pipeline would be trip to Antarctica to gather data and study stars. So there are many projects which are we are lining up in Fern. So please do check it out. Our site fern.myfreesite.net. We'll be leaving the link in the description. And one of our main goal is to make a flat earth documentary, a professional flat earth documentary also too. So thank you everyone for coming in. Yeah.
Well, right now the document is in Spanish. In a couple of days will be in English. Maybe one day will be in English too. So for now, you can download in Spanish and it's fine. And tomorrow probably you can download in English.
Exactly. Tomorrow, with all the information, you can download it right now in Spanish, but you have all the information. But we're gonna do it tomorrow. We're gonna have it in English, where you can see all the modifications we have been done from the old map to the new map. So there you have it, people. This is there's been a lot of effort being put in here to get this map to the community, because we are tired of people just speaking and doing nothing. They're not taking the community ahead, and criticism and wasting of time. We have choose to take this step ahead because we need the community have come to a point. There's real observations and experiments, and science is needed to get to our real map.
Gregor, the flight from Sydney to New York and to Santiago, that is the longest flight that normally create a lot of headache to the flat earth community, works on
Yeah.
this map. And the size are very accurate, but we cannot trust in Google Earth and the distance that provide regular information. So it's something that we must to check step by step. I will consider for our next slide this flight based on our
For
map.
sure. For
Okay,
sure, sure. It was really,
thank you
yeah,
so much.
yeah, it was really a,
I go
yeah,
south.
yeah, it was really, yeah, it was really a pleasure to have you here, Celino. So Celino is our team leader for this specific project about building our map, and our Fern team is ready to go ahead and do more of flat earth truth.
This is big movement and it's very popular in Spanish. And right now we are trying to to share with the English community too. So we know the language is a little bit complicated, but it's very interesting because it's an improvement from Gleason Maps. So we need that the community share this map and show to the community that we can do real research, we can do real investigation, we can improve that what we have 4 years stopped like community, and this cannot continue. We can do very good stuff and very good research with the information that provide, and maybe the resource that we can get to create a more accurate point of view of what is the world that we are living on.
Exactly. So everyone have a really great season. Greetings for everyone. Enjoy your holidays with your family. And see, this is a gift for our Flat Earth community right now to hold on to a new Flat Earth map 2020 0.1, brought to you by Fern. Thanks for everyone for joining in this live. Celino, thank you very much for this contribution. We all are this is our team effort to
So,
get this here.
thank you, my friend. We will share these videos in all our communities too. Thank you so much. Bye
Thank
bye.
you. Yes. Thank you. Good night, everybody. This is Wika and Celino signing off from Fern Live. Thank you. Bye.